In this session, we will learn how to design a VQ system and how to compute the rate of VQ quantizer. When an arbitrary vector xi is input to the vector quantizer for vector quantization, the vector quantizer first determines which subspace it belongs to, and then outputs the representative vector yg of the subspace. The distortion measure is used to compute the difference of the input vector and the centroid vector. The subscript of the corresponding centroid, which minimizes the distance, will be saved and transmitted. All the subscripts will form into code labels. All the centroids will form into code words or code vectors, which constitutes the codebook. The codebook is trained from a large database with some kind of VQ design algorithm, like k-means, GLA, and LBG algorithm, which will be introduced next session. Vector quantizer contains VQ encoder and decoder. The function of the encoder is to search for the code vector or code word that best matches the input vector S according to some distortion measure. Given an input vector, the closest code word is found, and the index of the code word is sent through the channel. At the decoder, this index is used to look up the code vector from an identical codebook. When training codebook, the distance between two vectors will be represented by the distance between two centers. It could be pre-calculated as soon as the codebook is obtained. So, during the VQ decoder, whenever the code is obtained, the calculation will be a kind of looking up table operation. Compression in VQ is achieved by using a codebook with relatively few code vectors compared to the number of possible input vectors. The resulting bit rate of a VQ is given by R, which is the number of bits per dimension, in which B is the number of bits per codebook, N is the size of codebook, K is the dimension of code vector. The rate R is proportional to the size of codebook N, and inversely proportional to the dimension K. There is a second definition of VQ rate, which is computed by the output entropy of vector quantizer. The probability measure of quantized vector in codebook is obtained to compute the entropy. Transmission rate in the channel will be the product of sampling rate and VQ rate. Here is an example of computing vector quantizer rate for speech coding. There are some parameters like LSP coefficients that can be quantized with VQ method. Given that the size of codebook is n equals 256, dimension of code vector k equals 8, sampling rate fs equals 8 kHz. According to the equation, the rate of VQ encoder will be 1 bit per dimension. The transmission rate RT will be 8 kilobits per second. Two definitions of vector quantizer rate lead to two concepts of optimal vector quantization. Under two different conditions, the vector quantizer with the smallest distortion is obtained, which is called the best vector quantizer under this condition. The first optimal vector quantizer is defined by giving the size of VQ quantizer n. The smallest distortion is computed within the collection of all k-dimensional vector quantizers with code size n. In speech coder, n and k are defined before encoding. The rate of VQ is fixed for each frame. The second optimal vector quantizer is defined by giving limitation of the output entropy R. The smallest distortion is computed within the collection of all k-dimensional vector quantizers with output entropy Hx less than or equal to R. Because of the size of codebook is not defined, the VQ bit rate can be variable for each frame. Given the limited output entropy, the actual design of VQ is difficult due to the unknown codebook size n. We only discuss the problem of the optimal vector quantizer when the size of vector quantizer is known. Considering the size of codebook n is given, there are two conditions of optimal VQ. The first condition is to optimize the encoder, which will find the best division of the source space to minimize the average distortion under the condition of a given codebook. The first condition can be gotten by nearest neighbor principle, NNR. The second condition is to optimize the decoder, which will find the best codebook to minimize the average distortion under the given division condition. The second condition can be gotten by k-means method. There are two problems in the designing of VQ system. The first one is how to divide M regional boundaries. This process is called training or establishing a codebook, often using a clustering method. The method is to divide the frame parameter vectors from a large number of signals statistically, and further determine the center vector values of these division boundaries to obtain the codebook. The second one is how to determine the measure when two vectors are compared. This measure is the distance between the two vectors, or the degree of distortion based on one of the vectors. It describes the cost to be paid when the input vector is represented by the vector corresponding to the codebook, which affects the clustering effect and quantification accuracy. Next session, we will talk about the design algorithms of codebook. That's all for this session. See you next session.